right, here's the next set of problems. So we have circles now, which really don't make a difference. We can still break circles into different parts. So again, we're going to look at what the first model equals. So how many parts we have is what we're going to look at first. So we have 1, 2, 3 parts, so 3 equal parts. And only one of those parts, we'll do that in blue, only one of those parts is shaded. So 3 equal parts and only one is shaded. So our denominator is how many pieces we have, and our numerator on top is how many pieces are shaded. So we have 1/3. So this picture right here is showing 1/3. If we move on to the next one, it says when divided into equal parts, what does your model equal now? So we're looking at the parts. How many parts do we have now? Well, we have 1, 2, 3, 4, 5, 6. So remember, the total parts, equal parts, is your denominator. And then, how many parts are shaded? Well, we have 1, 2. So there are 2 shaded parts, 2. So our fraction here is 2/6. So we started with 1/3, and now we have 2/6. These are equivalent fractions, or they're equal to each other. They have the same thing. They take up the same amount of space. You can see the red on the first picture is the same amount of red on the second picture. All right, now on these, we are breaking them into more pieces. So we're going to count the pieces again. I'm going to do this in blue so it doesn't get confusing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. All right, so we have 9 total equal pieces. So I'm going to put 9 here, and that's also our denominator because our denominator tells us how many equal pieces we have. And now we're going to look at how many of them are shaded. So 1, 2, 3. There are 3 pieces that are shaded. So 3 shaded parts. So our fraction is 3 out of 9. So going back to our first fraction, we had 1/3, and then we had 2/6, and we said those were equivalent because the red shaded part took up the same amount of space. Now we're going to be looking at this next fraction, and that is showing 3 out of 9. All right, you might start to see a pattern here on how you can tell if a fraction is an equivalent fraction to another equivalent fraction. We will talk about that in a second. Now, what we have is one more to look at. So we're going to count all the pieces up and see what our fraction is. So we'll do that in blue again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 equal pieces. That's our denominator, how many pieces we have. And we have how many shaded in. So let's shade them in. We have 1, 2, 3, 4. 4 shaded in pieces. So we have 4 out of 12. And now we're going to look at all of our equivalent fractions that we made. So we have 1/3, 2/6, 3/9, and 4/12. All right, so looking at the numbers, you can kind of see a pattern. So if you're looking closely, you can see all I'm doing to get from my first fraction to the second is multiplying the bottom and the top by 2, right? If I wanted to go from the first fraction to the next fraction, I'm multiplying by 3. All right, that's a rule with fractions. You can make equivalent fractions by multiplying the numerator, which is the top, and the denominator by the same thing. All right, so if I wanted to make another equivalent fraction to this, I could say maybe I'll multiply 1/3 times 5, right? So I'm going to multiply both the top and the bottom by 5. So if 1 times 5 is 5, and 3 times 5 is 15. All right, see, it's following the pattern, and that will be an equivalent fraction. It'll be really small pieces because notice all the pieces are getting smaller when our denominator is getting bigger. So 15 will be very small pieces, but that's another equivalent fraction.